Hello everyone, welcome back to the second video lecture series of 8086 architecture. So here in the last class or in the last lecture series, we discussed about the 8086 architecture and bus interface unit as well as its various segment registers. So now we'll get deeper into the various segment registers. The first one was the code segment register, and this is the data segment register. So again, the data segment register is a 16-bit segment register, and this points to the current data segments and operands for most of the instructions are fetched from this segment. The 16-bit contents of the source index SI or the destination index or the 16-bit displacement are used as offset for computing this 20-bit physical address. So now coming to the stack segment register. This is again a 16-bit register and it points to the current stack. The 20-bit physical stack address is calculated from the stack segment SS and the stack pointer SP for the stack instructions such as push and pop. In base addressing mode, the 20-bit physical stack address is calculated from the stack segment and the base pointer BP. The extra segment register, which is again a 16-bit register and points to the extra segment in which the data that is in excess of 64K pointed by the DS is stored. The string instruction uses the ES and DI to determine the 20-bit physical address. And coming to the next pointer, that is the instruction pointer, it is 16-bit and always points to the next instruction to be executed within the currently executing code segment. So this register contains the 16-bit offset address pointing to the next instruction code within the 64 KB of the code segment area. Its content is automatically incremented as the execution of the next instruction takes place. So now moving to the instruction queue. So this is very, very important because the instruction queue helps in taking care of the pipelining of the instructions. So generally, the pipelining of the instruction means while one of the instruction is being executed, the other instructions are simultaneously being fetched into the queue. So why should this actually happen? So this is one of the main features of 8086 when compared with 8085 because this helps in drastically reducing the instruction time or one timing cycle or one machine cycle of the instruction. Because once the instructions are being executed, the other instructions are being queued up so that once the present instruction is over, the next instruction can simultaneously work and help in providing the result. So the size of this is nothing but 6 byte. So there comes a question, are all the instructions 6 byte? No, it is not like that. The instruction set can be of any size. We never know what are all going to be the instructions that are actually queued up in the pipeline. But still, we say that the maximum size where how much it can be queued is about 6 byte. So now moving to the EU. And the EU is a very important area which helps in executing the instruction. Generally, a decoder in the EU control system translates the instruction. Why? So because we all know that when the instructions are fetched from the memory, the instructions will be stored in the form of binaries, that is zeros and ones. And this has to be decoded in such a manner that the instruction has to be executed in the microprocessor. So the decoder in the EU execution unit translates all the instructions. So here A 16-bit ALU is used for performing the arithmetic and the logic operations, and the four general purpose registers, as we know, AX, BX, CX, and DX, do also help in this operation as seen earlier. So some of the 16-bit registers can also be used as 2-bit registers. Again, I'm putting the question in front of you. Can you say how AX is being put as two 16-bit registers? Sorry, two 8-bit registers. Yes, they are split as AH and AL. AL is the lower order byte and AH stand for the higher order byte. So likewise, BX, CX, and DX can be split into two 8-bit registers. Again, BLBH, CLCH, and DLDH. So the index registers such as the source index and the destination index are all of 16-bit registers, and they are used during the memory addressing. And they are also the offset address. So coming to the pointer registers, that is the stack pointer and the base pointer, they have their own role to do here. So let us all discuss about that in the upcoming video. So the assessment question here is that can you tell me what is pipelining, or what is the role of pipelining in 8086 architecture? So let us catch up in the next video lecture series, in the continuation of execution unit. Thank you.